Hi, this is Bill. This is KubeFM.
So first things first, who are you, what's your role, and where do you work?
My name is Bill Shelton. I am responsible for the product organization at the Observability business unit within Palo Alto Networks. And this is a team that just up until about 2 months ago was Chronosphere. And actually, we still hold on to that name, but now, of course, under some new ownership. And yeah, there you go.
So Bill, what are 3 emerging Kubernetes tools that you're keeping an eye on?
Well, one, if you give me some license, it's not emerging. It's been around a little bit, but I find it super provocative because it really just gets at evolving the architecture itself. WASM is just so lightweight that I'm interested to see how that plays out. That's one that I definitely keep my eye on. I am also interested in seeing what's taking place on the edge. So, some like unified control planes, the Cordant, Tiger Calico, cluster mesh, those I think are very interesting in thinking about clusters of Kubernetes that are on the edge and very large in scale. I find that super interesting, tracking that always. And then, of course, the emergence of more kind of agent-focused management platforms. Sentinel-1 is one. There's various other ones providing a larger set of, either endpoint detection, response capabilities as containers are used more and more for agents. There's 3.
Okay.
We can go on here for. But
I'm sure we could. I'm sure we could. Yep, no shortage of tools in the Kubernetes ecosystem. Now, managed Kubernetes services keep promising to remove operational burden. At what point does abstraction stop being helpful because your team can no longer explain or debug what happened in production?
It's a great question. There's a couple thoughts on that. I think in the heat of the moment, when you are in, and you have a high severity call and maybe an outright incident, you need to work through that data to get to root cause so you can remediate the situation. One of the most frustrating things is to have an abstraction layer that is preventing you from getting to that next level. So, one strategy that we definitely lean on extensively at Chronosphere is not really having hard abstractions, but having aggregations that provide the ability for someone to see things at a larger level, very quickly break through the abstraction and cut through and redimensionalize the data. We actually have a tool that instead of it provides you a guided path. We call it our DDX tool. And what it's doing is behind the scenes is running threads to actually analyze where there's correlations around the error condition. So an increase in 500s here. We also have found that we have an anomaly on CPU in various places. We also found we had an anomaly on a container level diagnostic. And we will redimensionalize the data at that point to then bring focus on the intersection of all of those different dimensions that are at different layers of the abstraction that might accelerate your path to the issue. So we give you a default schema that you could just walk through, and you could walk from cluster and you can look at the Kubernetes services and maneuver around, but we accelerate you through that to actually find common correlations and then redimensionalize the data by those. So it's a little bit less about forcing an abstraction on people versus searching around the abstraction and then creating a new kind of model or schema for them to walk through to get to the issue. So that's our thinking on it right now and what are the strategies we use.
One of our podcast guests, Fernando, describes discovering that his GKE autopilot proof of concept was costing close to $1,000 a month due to balloon pods, minimum CPU to memory ratios, and unexpected metrics charges. How do you handle cost visibility in managed Kubernetes?
A couple of things. You do the basics. We integrate with KubeCost and try and take advantage of the ecosystem around us where people have some investments to help them manage costs. But that's really just the start of what we do. A couple of things. We have found a relationship. We view cost control and acceleration of troubleshooting actually are complementary problems. We found kind of two sides of the same coin. So we spend a lot of time, we provide a whole rich tool set that I'll talk about in a moment to just minimize the data you have. Stepping back for a moment, in many ways, I think we've all had this discovery where you take traditional legacy observability tools and you drop containers in, and just because of the volume of the order of magnitude increase in the number of code paths that are emitting metrics because of microservice architecture and a large horizontal scale out, all of a sudden your data volume just explodes. So the first thing we do is give you a whole vocabulary to set up what we call drop rules. First thing we do is, for all the data that's loaded, we then, first of all, we track every access point to every metric. And when you can imagine, when you get to every high cardinality environments, very large environments, you're dealing with hundreds of thousands of metrics. We track every single access point to those metrics, which means that right off the bat, and then we use that to then assign a utility score. So this utility score becomes a big part of how you can go and look at your data, and right off the bat, identify all the metrics that are never used. They're not part of a dashboard. They haven't been used as part of any ad hoc interrogation over the past 30 days. Great. This is a very low value metric. Drop. And we just let people manage things aggressively in that way. And with this score in hand, they will be able to set up drop rules, which means, hey, it's never even kind of brought into the system. And then other rules where we say, hey, you know what? Yeah, I want to hang on to that, but I'm only using it occasionally. I'm only using it in the aggregate. So when you do bring it in, here's an aggregation rule. And now we can aggregate so that we can get rid of some of those more fine-grained windows to then, again, further reduce the size. So the result of this is that we find two things taking place. People just naturally, are saving a large amount of money because just the raw, most of the vendors out there are charging by some form of either throughput or stored data. And then at the same time, we find this actually really accelerates their troubleshooting when they're actually, you got a lot less a noise to kind of sort through there when finding signal. Systems responding faster, less data. You're dealing with higher value data. So that's our approach. We load people up with a lot of tooling to help them kind of set policies to optimize their environment that way.
Now, another podcast guest of ours, Molly, believes many people initially think they need their own cluster because they are scared of multi-tenancy, but they learn that the operational overhead of maintaining multiple clusters is significant. What is your experience with teams being scared of multi-tenancy versus dealing with operational overhead? It's
a good question. I'll lean back a little bit because I think there's lessons we can learn from. Obviously, clusters have been part of our world for a long time. Kubernetes uses them, but many other previous technologies. And I actually did a fair amount of work at VMware, and we studied this problem we had the benefit of a very large customer base. We could look and see how many clusters are being used, how many were at capacity, and really start to unpack this problem. And in that context, we learned a couple of things. One of which is that frequently additional clusters on the margin are not created because the previous cluster was at its capacity. It was some organizational or business issue that was driving the additional cluster. Sometimes it was the boundary on budgets or the org chart or something like this. So that's the result of it. There are going to be a lot of clusters out there. And I think that, what we adhere to, I see other vendors adhering to, for some of the key management capabilities, your, identity and access management, cost management, observability, those need to rise to above cluster level and be able to bring data in and both from a scale as well as have a schema that it fully expects multiple clusters to come in and then provide someone the ability to problem solve, manage, track SLOs across clusters. So that's generally what I see playing out, is that part of the industry is going to that higher level where they'll work across clusters. while Kubernetes is still doing great things, mostly within cluster.
Kubernetes turned 10 years old about 2 years ago. What should we expect in the next 10 years?
I go back to, kind of already played my hand here a little bit. I think serverless and WebAssembly, while some lighter weight models, I think we will see. 10 years, I can't even imagine, but definitely over the next 4 to 5 years, I think we will see more and more as agents start to play a greater role in the applications that are out there, where you have very transient, short-running, independent processes on independent code paths. I think that side of Kubernetes, the Knative and WASM and things of that would play a much more dominant role. Or as a proportion of the containers that are running out there, I think we'll see an increase in that form.
And Bill, what's next for you in terms of projects, events, plans? What you got going on next?
We are spending a lot of time very excited in looking at what I think the industry is framed up. I haven't seen it fully realized yet, but I believe it's out there for us, is the, what's sometimes called the AI SRE. And we don't believe at that point that is a substitutive play. Our assessment is that there is still such a rich cognitive process taking place, in particular in a troubleshooting phase. We don't view this as a substitutive moment in the industry, but we definitely see it as augmentative. And we definitely see it as a accelerator in those critical times when someone is working an issue. So we have some interesting projects and specialized agents that are upon a incident being triggered, are immediately going off and curating data, creating some of this dimensions on data, doing research, hitting previous incident reports to maybe glean insights, and just bring a lot of data and then help that person process through it, where we're not just heaving it unlimited data onto someone and almost making their situation more stressful, but helping prioritize it, synthesize it to really optimize what is that kind of game day experience when there's an issue that needs to be tended to.
And if people want to get in touch with you to continue the conversation, see what's going on next, what's the best way to do that?
Go to chronosphere.io, and then maybe at some point that would redirect over to Palo Alto. Maybe it does today. But anyway, chronosphere.io, you learn about, some of the work we're doing, for some of our largest customers, and go from there.